So if you've been following the channel so far, you would know that I've started a series of questions for IGCSE 0580 mensuration part. So basically what I've done is that I've created a spice meter where I'm sharing mild questions first, which are basically the easy questions. Then we have the spicy questions, which are slightly difficult compared to the easy ones, obviously. And lastly, we have the hot ones, which are the most difficult questions that I came across from 2020 onwards. So if you're someone who struggles with mensuration most of the times, then this video series is perfect for you. If you think you need help with the basics, then you should check out the mild ones first, for which I'm attaching the link above. If you think you're more well-versed with the topic and just need some brushing up with the skills, then you can begin with the spicy ones or the hot ones. So let's start with the questions. 5 says all the lengths in this question are in centimeters. The diagram shows a shape ABCDEF made from two rectangles. The total area of the shape is 342 centimeters square. So as you can see, we have a composite shape, which is comprising of two rectangles. The area of the total shape, like the composite shape, is 342 centimeters squares. We have to show that x squared plus x minus 72 equals to 0. So using the area and the given lengths, we're going to find an equation that relates all of this. And then as we simplify it, it turns into x squared plus x minus 72. So if we call this A and if we call this B, area of A is going to be length times width. The length is x plus 1. The width is not given. How do we figure that out? Now we can see that the entire length AB is 2x. And a part of AB, which is DC, because this is equal to this, is x plus 3. So which means EF is going to be the difference of 2x and x plus 3. Now, if you notice, the reason why I put brackets over here is because we're subtracting x plus 3 from 2x, not just x. This is a very common mistake that kids make. Like they just write 2x minus x plus 3. The brackets play a huge role because then they're showing that we're subtracting the entire x plus 3 from 2x, not just x. So that's going to be 2x minus x minus 3, which is x minus 3. So for the area of A, now we'll do x plus 1 times x minus 3. So now what we do is to expand the brackets. It's going to be x times x plus 3 and plus 1 times x minus 3. This is minus. So that's going to be x squared minus 3x plus x minus 3. It simplifies to x squared minus 2x minus 3. Now moving on to the area of B. The length is 4x minus 5 and the width is x plus 3. So for x minus 5 times x plus 3. So for x times x plus 3 and negative 5 times x plus 3. That's going to be 4x squared plus 12x minus 5x minus 15, which further simplifies to 4x squared plus 7x minus 15. So now these are the separate areas of A, like the top rectangle, and B, the bottom rectangle. Now the total area is 342. That means 342 equals to the sum of these two. So x squared minus 2x minus 3 plus 4x squared plus 7x minus 15. Now, if you're wondering why didn't I add brackets over here around 4x squared plus 7x minus 15, the reason is because now we're adding. In addition, it doesn't make a difference if the brackets are there or not. But in subtraction, it does because the 3 would become negative as well, not just x. So that's why the brackets aren't important over here. So that's 342 equals to x squared plus 4x, which is 5x squared, negative 2x plus 7x plus 5x, and negative 3 minus 15, which is negative 18. Now we collect all of the terms on one side. So 342 would go on the right-hand side. So that's going to be 0 equals to 5x squared plus 5x minus 18 minus 342, which gives us 5x squared plus 5x minus 360. So since 5 and 360 are both divisible by 5, so when we divide the entire expression by 5, what we get is x squared plus x minus 72 equals to 0. Then it says solve by factorization. So same equation, now we're supposed to just factorize it and find the values of x. So x squared plus x minus 72 equals to 0. I'm going to use splitting the middle term. You can use the quadratic equation as well. Either it's going to be correct because they haven't given a restriction in the question. So whichever method you're comfortable with, just use that and find the values of x. So for splitting the middle term, what we do is we multiply the coefficient of x squared with 72. Now the coefficient of x squared over here is 1, which means 1 times 72 equals to 72. Now, once we've done the multiplication, we find factors of the product from the previous step. So factors of 72, what are those? Apart from 72 times 1, we have 2 times 36. We have 9 times 8. And we have 3 times 24. So these are the factors of 72. Now we have to pick that set of factors which when added or subtracted gives us the middle term. Now the middle term over here is x, and that has a coefficient of 1. So we basically need a 1. So we can say that 9 minus 8 equals to 1, which means this is the set of factors that we will choose to replace the middle term now, which means the equation becomes x squared plus 9x minus 8x minus 72 equals to 0. As you can see, all we did was replace the middle term with a set of factors that we chose. So if we just solve this equation as it is, it goes back to the first equation. But we split the middle term so that we could factorize this. And the next step, what we're going to do is factor by grouping. So in factor by grouping, what we do is we split the equation into two groups. First two terms make one group and the last two terms make another group. So now using this, we're going to further factorize this equation. So now in the first group, we have x common. So it becomes x times x plus 9. And the second group, we have negative 8 common. And the bracket we're left with x plus 9 as well. So as you can see, both x and negative 8 have x plus 9. So you can take the x plus 9 common. And the other bracket will be left with x minus 8. So one value of x is going to be negative 9 and the other is going to be 8. These are your answers. Then part C says work out the perimeter of the shape ABCDEF. Now if you remember the previous part, we got x equals to 8 and x equals to negative 9. Now obviously we cannot use negative 9 because like the lengths cannot be in negative. They have to be positive. So we'll use x equals to 8 to find the measurement of the lengths of the composite shapes and find the perimeter of the shape ABCDEF. So as you can see, AF will be 8 plus 1, which is 9. AB will be 2 times 8, which is 16. BC will be 4 times 8 minus 5, which is 32 minus 5, and that is 27. D would be 8 plus 3, which is 11. Now, FE was found to be 16 minus 11, which is 5. And ED would be 27 minus 9, which is 18. So these are all of the lengths. So your perimeter would be 9 plus 16 plus 27 plus 11 plus 18 and then plus 5. And that is going to equal to 86 centimeters. That's your perimeter. Then it says calculate the angle DBC. So you draw a line that connects DB first. This is the angle they want us to find. So this was 11. This was 27. So to find this angle, we can see that this is a right angle triangle because every angle in a rectangle is 90 degrees. So we can easily use SOHCAHTOA. Remember, in right angle triangles, either use SOHCAHTOA or Pythagoras. Pythagoras is used when you're trying to find one missing length and the other two lengths are given. Whereas SOHCAHTOA is used when they have given us a length or an angle and they want you to find another length, or they've given us two lengths and they want you to find an angle. So based on our measurements, we have the opposite, which is the length opposite to the angle, and adjacent is the length on which the angle lies. So we're going to use tangent. So tan theta equals to 11 over 27, and theta would be tan inverse of 11 over 27, and that is going to give us 22.2 degrees. And this question says that the diagram shows two triangles. Calculate QR. So if we highlight the triangle over here, PQR, we can see that in this triangle we have two lengths and the angle between them. So if you recall your rules for non-right angle triangles, if a triangle has two lengths and the angle between them, that means it qualifies for the cosine rule. So to use the cosine rule, we need two lengths or the angle between them. Or if all three lengths are given and they want you to find the angle, then you can also use the cosine rule. So over here, since QR is what we're trying to find, so QR square equals to PR square plus PQ square minus 2 times PR times PQ times cos of angle P. So QR square equals to 150 square plus 120 square minus 2 times 150 times 120 times cos of 25. And now when solving the cosine rule, what you need to remember is that you need to solve this part separately first and this part separately. The reason why I'm asking you to solve these parts separately is because what most students do is that they do the 150 square plus 120 square, and then they subtract 2 times 150 times 120 from it. They forget to multiply cos 25 with 2 times 120 times 150, and then you have to subtract that entire product from the sum of these two squares. Not subtract the 2 times 150 times 120 separately, and then, multiply it by cos 25. That's completely wrong. That's why I split the equation into two boxes that, you have to solve that box separately and that box separately. So 150 square plus 120 square, that gives us 36,900. And the other one, that's 2 times 150 times 120 times cos of 25. And that is 32,627.08. So now we subtract the two. That gives us 4,272.92. And to find the value of QR, you will square root both sides. And QR equals to 65.4 meters. That's your answer. So remember, cosine rule is only applicable when you have two lengths and the angle between them, or you have all three lengths. Then it says calculate RS. So now RS is in this triangle. PRS. So you need to find this. So now you can see that we have two angles in this triangle and you have one length. So if we have two angles, we can easily find the third angle using the sum of angles of a triangle. So angle S is going to be 180 minus 55 minus 45, which gives us 80 degrees. So we have angle S, that's 80 degrees. Now if we look at the information for this triangle again, we can see that we have all three angles and we have one length PR. Now if we look at the angle and the length given, we can see that we have one complete set of angle and its opposite length. So what does that remind us of? That reminds us of the sine rule. Sine rule is applicable when you have one complete set of angle and length. When I say the phrase one complete set of angle and length, what I mean is an angle and its opposite length. So this one complete set means that we can use the sine rule. Because if we notice, we have the other two angles and they're asking for the length of one of those angles. So if you remember sine rule says A over sine of angle A, which means if this is angle S, this is length of S. This is angle P, this is length of P. This is angle R, this is length of R. So A over sine of angle A equals to B over sine of angle B equals to C over sine of angle C. The capital ABC represent the angles and the small ABC represent the lengths. So in our case, we have S, we have angle P, and they want us to find the length of P. So we'll do 150 over sine 80 equals to RS over sine of 55. So RS would equal to 150 sine of 55. We cross multiply this and it's divided by sine of 80 and that gives us 124.7 meters. That is the length of RS. So as you can see in this question, you covered both sine rule and cosine rule and the conditions in which they're applicable. Then part C says calculate the total area of the two triangles. We go back to the diagram and as we can see, we have two non-right angle triangles, which means we cannot just do 1 over 2 times height times base. That is only applicable if it's a right angle triangle or they have given us the base and the perpendicular height for the triangle. Over here, there's no perpendicular height. So the formula we use is area equals to 102 times A times P times sine of angle C. So for us to apply this formula, the condition is similar to the cosine rule. We need two lengths and the angle between them. So keeping that in mind, if you look at the first triangle, we know this was 80 and this came out to be 124.7. For QR, we got 65.4. So these were our lengths and angles. So if you look at the triangle PRS, we have SR, we have PR, and we have the angle between them. So you can use the formula for this triangle. And for the other one, we originally had PR and PQ and the angle between them. So both these triangles can use this formula without any additional calculation. So what we can do is for the area of PSR, we can do 1 over 2 times 124.7 times 150 times sine of 45. That gives us 6,613.2 meters square. Then for area of PQR, we'll do 1 over 2 times 150 times 120 times sine of 25. That will give us 3,803.6 meters square. So now total area is going to be the sum of these two, 6,613.2 plus 3,803.6, and that is going to give us 10,416.8 meters square. Next question says the diagram shows the positions of 3 points A, B, and C in a field. Show that BC is 118.1 meters correct to 1 decimal place. So once again, as you can see, we have two lengths and the angle between them, which means we'll apply cosine rule. So BC square equals to AB square plus AC square minus 2 times AB times BC times cos of angle A. So that's going to be 80 square plus 115 square minus 2 times 80 times 115 times cos of 72. That's going to be 19,625 minus 2 times 80 times 115 times cos of 72, which is 5,685.91. Subtract the two, and what we get is 13,939.09. Now we square root both sides, and that equals to 118.06 meters. Then it says calculate angle ABC. So angle ABC is going to be this one, angle B. Whatever letter is written in the middle, that is where the angle lies, not the letter at the beginning or the letter at the end, the letter in the middle. That is the angle. So the angle over here lies at B. So we found this one to be 118.1. So what we can do is we can use the sine rule. Why the sine rule? Because as I said in the previous question, sine rule requires you to have one complete set of angle and length. So that one complete set of angle and length over here is angle A and length of A. Over here, we need angle B, but we have the length of B. So that meets our condition. With one complete set, you can find the missing information for the other set. So that's going to be 118.1 divided by sine 72 equals to 115 over sine of angle B. Cross multiply. So sine of angle B equals to 115 times sine 72 divided by 118.1. So 115 sine 72 divided by 118.1. that equals to 0.92609. Angle B would be sine inverse of this. And that will give us 67.8 degrees. That's your angle ABC. Part C says the bearing of C from A is 147. Find the bearing of A from B. Bearing of C from A is 147, which means this is 147. Remember, bearing is always measured from the north in clockwise direction. And if it says bearing of C from A, that means you will measure the angle at A, not at C. Where it's from, you measure the angle over there. So we start measuring from north in the clockwise direction, and the angle goes till the line which connects the 2 points that we're talking about. So this entire angle is the bearing of C from A. Now they want the bearing of A from B. So to find the bearing of A from B, take your compass at B and this is the angle that they want. This is the bearing. You start from the north at B because we want the bearing of A from B. So at B, we draw the compass. We start measuring from the north in clockwise direction and measure the angle till the line where A and B are connected. So now we know this part of the angle. This is 180. So all we need is this angle. So if we come to think about it, we already found angle ABC, this one, which was given as 67.8 degrees. So if this is 67.8 degrees, we can see that this over here is 72. So to find, let me color code this angle, 147 minus 72, and that equals 75. So if you remember parallel lines, in parallel lines, if you have two parallel lines and you have a transversal passing through them, alternate angles are equal. So same concept is applied over here when we're trying to find bearings. The two norths, which are at A, which are at point A and point B, they're also parallel. And the line connecting A and B is the transversal passing through those two parallel lines, which means the angle at the top of this line, which is 75 over here, is the same as the angle at the bottom of this line. This one, this is also 75. So since we said that the bearing of A from B, which is measured from the north of B in clockwise direction, is this entire angle that's coming from the north and going till the line connecting A and B. So our bearing will be the sum of $180 and 75, which is equal to 255 degrees. Remember, bearing is always measured in clockwise direction from the north of the point from which they're asking you to find the bearing. And secondly, bearing is always written as a 3-digit number, not 2 digits. For example, your bearing was 25, you would write it as 025, not just 25. If the bearing was 5, you would write it as 005. So it's always written as a 3-digit number, not a 2-digit or a 1-digit. Then the second part says, find the bearing of B from C now. Now to find the bearing of B from C. First, we draw the compass at C. Like I said, we're going to measure the bearing from the north of C towards the line that connects B and C. So that's this. This is the bearing that we need to find. Now, if you remember from part B, angle B was found to be 67.8. So we can see we have two angles in the triangle and we need the third one to figure out how to find the bearing. So to find the third one, what we'll do is that we will subtract 72 and 67.8 from 180, and that gives us 40.2 degrees. So this entire angle is 40.2 degrees. Now, if you look at the north at A, we know that in the question they mentioned that the bearing of B from A is 147. So if we extend this line over here, we can easily find this angle beneath the line that connects A and C. This is going to be 180 minus 147, which is equal to 33 degrees. So this is 33 degrees. Like I mentioned before, when you have two parallel lines and it has a transversal passing through them, angle at the top of the line equals to the angle at the bottom of the line. Basically, alternate angles are equal. So this 33 degrees is equal to this angle over here. Now, if you notice, this angle is on the left-hand side of the north at C, and it's above the line that connects A and C. So this is 33. So if this is 33, and this 33 is a part of this 40.2, if we subtract the two, we can easily find the bearing of B from C. So bearing of B from C equals to 40.2 minus 33, which equals to 7.2. As I mentioned earlier, bearing cannot be written as a two-digit number or a one-digit number, which means we'll add two zeros before it. So 007.2 degrees is your bearing of B from C. And it says Mitchell takes 35 seconds to run from A to C. Calculate his average running speed in kilometers per hour. So from A to C, your distance was 115 meters. So distance is 115 meters. He takes 35 seconds to run from A to C. They want the average speed in kilometers per hour. Let's convert the distance into kilometers first. 1 kilometer is equal to 1,000 meters, which means 1 meter equals to 1 over 1,000 kilometers. So that's going to be distance in kilometers is 115 divided by 1,000, 0.115 kilometers. Then for time, your 1 hour is 60 minutes. 1 minute is 60 seconds, which means 1 hour is 3,600 seconds, and 1 second is 1 over 3,600 hours. Remember, when you're going from a smaller unit to a bigger unit, you divide. But if you're going from a bigger to a smaller unit, you multiply. So over here, 35 seconds is going to be converted into hours. So we're going to divide 35 by 3,600. And that gives us 0.00 972 recurring. So average speed is distance over time. So that's 0.115 divided by 0.00972 recurring. And that equals 11.8 kilometers per hour. That is your average speed in kilometers per hour. Then it says calculate the shortest distance from point B to AC. Now, this is a very common question that comes in the paper, where it can come in paper 2 as well, and paper 4, depending on how many marks the question is for and what is the difficulty level of the question. So when it says the shortest distance from any point to a side, what they're asking for is the perpendicular length. So shortest distance from point B to AC is this, and this is the perpendicular height for this triangle in this direction. We know that BC is 118.1, and we have this angle C, which was found to be 40.2 degrees. So to find the shortest distance from point B to AC, which is this distance, let's call it X, we can see that we have a right angle triangle. We have a length, we have an angle, so we can easily use SOHCAHTOA to find the distance. Now looking at SOHCAHTOA, we need to figure out what we have. We have the hypotenuse. Remember, the hypotenuse is always the diagonal. Always. We have the hypotenuse, which means it's not tangent. We have the angle, and they want us to find this length. Now, the length opposite to the angle is always the opposite. And the length on which the angle lies, that is always the adjacent. So this is the adjacent, and this is the opposite. So in our case, we have to find the opposite. We have the hypotenuse, which means we'll use sine. So sine of 40.2 equals to x over 118.1. 118.1 times sine of 40.2 equals to x. Remember the 40.2, remember the 118.1 is always written before the sine, not after. You're not doing sine 40.2 and then multiplying it, the angle with the length, It's the length, then sine 40.2. If you do sine 40.2 times 118.1, that would give the wrong answer. So you're supposed to do 118.1 times sine of 40.2, and that gives us 76.2 meters. This is the shortest distance from point A to the length AC. Remember, the shortest distance is always the perpendicular distance, and that is mostly found by using SOHCAHTOA. So this is your answer. This question says, so the diagram shows a sector of a circle with center O, radius 8 centimeters, and sector angle 165 degrees. Calculate the total perimeter of the sector. So to find the total perimeter of the sector, what we need is the length of OA, the length of OB, and AB. Perimeter is the entire boundary of the shape, whereas area is the space that the shape occupies. So since OA and OB are the radius, so they're both going to have the length of 8. With the length of AB, what we need is the arc length. So perimeter is equal to your arc length plus twice of the radius. arc length has the formula of your angle, which is 165 divided by 360 times 2 pi r being 8, plus 2 times 8 because r is once again 8. So now you plug this in the calculator and what you should get is 39 centimeters. Then it says the surface area of a sphere is the same as the area of the sector. Calculate the radius of the sphere. So now for the sector, area equals to 165 over 360 times pi r square, r being 8. So when we plug this in the calculator, what we get is 92.15 centimeters square. This is area of sector. Now area of sphere is 4 pi r square, which is also mentioned in the question. So since the sphere has the same surface area as the sector and they want us to find the radius of the sphere, 92.15 is equal to 4 pi r square. 92.15 divided by 4 pi equals to r square. And that is going to be 7.33 equals to r square. Square root both sides to find the value of r. That is 2.71 centimeters. That's your answer. Then part C says a cone is made from the sector by joining OA to OB. Calculate the radius r of the cone. So OA and OB were the radius of the sector, and they've joined both the radius to create this cone. So now if you remember, this was our sector AOB. And this was 8, this was 8, and this was 165. So if you're joining OA and OB, which means your slant length over here, that's 8, because that was the length of OA. Other thing is that we found the arc length, which was 23. 165 divided by 360 times 2 pi r. So that was the arc length. So if you notice, the arc length is now becoming the circumference of your base. Base is a circular shape, and that is made by joining A and B over here. So which means the arc length is the same as the circumference of the base. So arc length was 23. 23 equals to 2 pi r. R is the radius of this base, circular base. So 23 divided by 2 pi equals to r, which is equal to 3.66 centimeters. That is your radius. Once again, if we do 165 divided by 360 times 2 times pi times 8, that gives us 23 centimeters as the arc length AB. So this 23 divided by 2 pi is 3.66 centimeters. That is your radius. Then it says calculate the volume of the cone, and the volume of a cone with radius r and height h is v equals to 1 over 3 pi r square h. So we just found the radius, which was 3.66, I told you that OA is 8. So as you can see, this triangle is a right angle triangle. And in a right angle triangle, if two lengths are given, I need to find the third one, which is the height in this case. We can use Pythagoras. So 8 square, which is the hypotenuse square, equals to h square plus 3.66 square. So that's 64 equals to h square plus 13.3956. 64 minus 13.3956. Take the square root to get rid of the square on h, which is 50.600044, and that gives us 7.11 centimeters as the height. So for the volume would be 1/3 times pi times 3.66 squared times 7.11, which is going to give us 99.7, which we can round to 100 centimeter cube as well. That is your volume of the cone. This question says the diagram shows a cuboid. AB equals to 8 centimeters, AD equals to 6 centimeters, and DH equals to 6 centimeters as well. Calculate angle HAF. This is the angle they want us to calculate. So if you notice, we have one right angle over here. Another one over here. And this one over here as well. If this is 6, this is also 6. If this is 6 and this is 6, this is also 6. And this is also 6. Sorry, this is 8. It's a cube, but not a cube. This length, these are 8. These are 6. And these are 6. Yeah. Okay, so all these are right angles because the cuboid has rectangular faces, and those rectangular faces have all right angles. So now, using Pythagoras, we can find the length for HF, HA, and AF. And once we have all three lengths, if you remember the conditions for cosine rule, you can use cosine rule if you have two lengths and the angle between them. In that case, you're trying to find a missing length. Or if you have all three lengths, you can also use the cosine rule, given that they're asking you to find the angle. In our case, once you find all three lengths, we can easily find the angle, which is HAF. So let's start with finding AH square first. So that's going to be 6 square plus 6 square, which is twice of 36. And that's going to be 72 square root that. So that's going to give us 8.48 centimeters. This is 8.48. Now for this one, that's AF squared equals to 8 square plus 6 square, which is going to be 64 plus 36, 100 square root that, and AF is 10 centimeters. Since this is also 8 and 6, so this is also going to be 10. So now that we have all three lengths, We apply the cosine rule to find the missing angle. So the cosine rule for finding the missing angle is cos of angle A equals to 10 square plus 8.48 square minus 10 square divided by twice of 10 and 8.48. That's going to give us 0.424. A would be cos inverse of 0.424, and that equals 64.9 degrees. That is angle HAF. So as you can see in this question, we applied two things. We applied Pythagoras because we had right angle triangles, and we used those to find the missing lengths. And once we had the missing lengths, we applied the cosine rule to find the missing angle. C lies on a circle with the diameter AD. B lies on AC. E lies on AD such that BE is parallel to CD. AB equals to 21 centimeters. CD equals to 18 centimeters. And BE equals to 13.5 centimeters. Work out the radius of the circle. So radius of the circle is basically your distance from the center to the circumference. This is what we need to find. So as you can see, triangle ABE is similar to triangle ACD. If you remember, similar shapes have a rule for length, area, and volume. And since in this case we're just dealing with lengths, so the rule we're going to apply is that each length, which is similar to the other shape, is enlarged by the same scale factor for each of the lengths. And by that, what I mean is that AB over AC would be the same as AE over AD, which would also be the same as BE over CD. Enlarging AB to AC uses the same scale factor as AE to AD and as BE to CD. Now looking at the information given to us, we have AB as 21. AC is not given, but if we call this X, then that's 21 plus X. AE is also not given. AD is also not given. BE is 13.5 and CD is 18. So if we use this fraction and this fraction, we can easily find the value of X. So let's put 21 over 21 plus X equal to 13.5 over 18. Cross multiply. So that's 21 times 18 equal to 13.5 multiplied by 21 plus X. So 21 times 18 is 378 equals to 13.5 times 21. That's 283.5 plus 13.5x. Take the 283.5 to the other side to collect the like terms. So 378 minus 283.5, 94.5 equals to 13.5x. Divide this by 13.5. And that gives us the value of 7. So BC is 7, which means AC is going to be 21 plus 7, which is 28 centimeters. Okay. Now that we have this entire length, next thing you need to notice is that ACD is a right angle. Why is it a right angle? It's a right angle because AD is the diameter, because it's passing from the center and both the sides of the length are touching the circumference, and any angle coming out of the diameter that is touching the circumference as well is 90 degrees, which is one of the circle theorems. Angles in a semicircle are equal to 90. So it's a right angle triangle. Since it's a right angle triangle, this is your C, this is A, and this is D. So AC is 28, AD is what we need to find, and DC is already given as 18. So we can easily use this to find AD, and then half of AD will be the radius, because AD is a diameter. And use Pythagoras to find AC. AC square equals to 18 square plus 28 square, which is going to be 1108. Square root both sides, and that gives us 33.29 centimeters. So radius is going to be AC divided by 2, which is 33.29 divided by 2, and that equals to 16.6 centimeters. That's your answer. So as you can see, in this question, we applied 3 different concepts. Firstly, we began with similar shapes. Then we used circle theorems. And lastly, Pythagoras to find the radius of the circle. Question 4 says a solid metal cone has radius 1.65 centimeters and slant height 4.70 centimeters. Calculate the total surface area of the cone. So total surface area of the cone has the formula of pi r square plus pi r L. As you can see, the curved surface area is already given in the question, which is pi r L, and pi r square is the area of the base, which is a circular base. So that's pi times 1.65 squared plus pi times 1.65 times L, which is 4.70. L is your slant height. H is your perpendicular height. So pi times 1.65 plus pi times 1.65 squared plus pi times 1.65 times 4.7, and that equals to 32.9 centimeters square. That's your curved surface area. Then it says find the angle the slant height makes with the base of the cone. So this is your slant height, 4.70. Radius was given as 1.65. And since the radius lies on the base, this is the angle that they're talking about. Now this is a right angle. Why? Because if we connect the cone, this is what it would look like. So now looking at this triangle, we can see that we have the measurement of the hypotenuse and one of the legs of the triangle. So we can easily use SOHCAHTOA. So from SOHCAHTOA, we need to decide which trig ratio will we use over here. We have the hypotenuse, so which means tangent is out. And since we have the length on which the angle lies, which is always called the adjacent, so we're going to use cosine. So cos of theta equals to adjacent, which is 1.65 over hypotenuse, which is 4.70. So theta equals to cos inverse of 1.65 divided by 4.70, and that equals 69.4 degrees. That is your answer. Then it says calculate the volume of the cone. So for the volume, we need the perpendicular height and we need the radius. So going back to our triangle, which was made in the cone, we have the slant height, we have the base, we have the angle, which is 69.4. But this is what we need, which is the height. So you can either use Pythagoras or SOHCAHTOA. Either will get the right answer. I'm going to go with SOHCAHTOA over here and use tangent. Tan of 69.4 equals to h over the adjacent. So 1.65 tan of 69.4 equals to h, and that gives us 4.39 centimeters. That's your height. So now volume would be 1/3 times pi times 1.65 squared times 4.39. Remember, the volume uses the perpendicular height, not the slant height. Slant height is only used in the curved surface area of the cone. So that's going to give us 12.5 centimeter cube. That's your answer. Then it says a metal sphere with radius 5 centimeters is melted down to make cones identical to this one. Calculate the number of complete identical cones that are made. The volume of a sphere with radius r is v equals to 4/3 pi r cube. So what we're going to do is that the volume of the cone is not going to change. So since we have the volume of the cone, we can easily use that to find the number of complete identical cones. But first we need to find the volume of the sphere, which will be 4/3 pi times 5 cube, which is 523.59 centimeter cube. The sphere. Now to find the number of cones, we divide the volume of the sphere by the volume of the cone, which was 12.5. Why are we dividing the volume of the sphere by the volume of cone? Is because we're melting the sphere to build identical cones, and those are the same cones that we saw in the previous part. So we're breaking down that sphere into cones. So that's why we're dividing the volume of the sphere by the volume of cones, so that we can know how many cones are made from that sphere. So when we divide that by 12.5, gives us 41.8. Since we can't make a cone in a decimal thing, so that the number of complete identical cones that are made is going to be 41. The 0.8 is removed because we're rounding it down because we need complete identical cones. In this question, it says that the diagram shows an open box A, B, C, D, E, F, G, H in the shape of a cuboid. AB equals to 20 centimeters, BC is 18 centimeters, and AE is 16 centimeters. A thin rod AGX rests partly in the box as shown. The rod is 40 centimeters long. Calculate GX the length of the rod, which is outside the box. So now if you notice, if we join point A with C and highlight these lengths, we have a right angle over here. So this right angle triangle, which is present diagonally in the box, can be easily used to find our value of gx. Now the total length of the rod, which is AX, is given as 40 centimeters. So if we can find AG, we can subtract that from 40 centimeters to get the length of GX. How will we do that now? As I highlighted, we have a right angle triangle in this cuboid. So in a cuboid, we have all rectangle faces, and each of the rectangle faces have right angles. So using those right angles, we can find the length of AC. GC is the same as AE, so that's going to be 16. So to begin with, let's find AC. AC square is equal to 20 square plus 18 square. As you can see, we're using Pythagoras. So that's the square root of 400 plus 324. So square root of 724. And that equals to 26.9 centimeters. So now, using Pythagoras again, I'm going to find AG. So AG square equals to 26.9 squared plus 16 squared. So that's going to be 724 plus 256, which is 980. Square root both sides. AG equals to 31.3 centimeters, which means GX would be 40 minus 31.3, and that is going to give us 8.7 centimeters. That's the length of GX, which is the rod outside the box. Then it says calculate the angle the rod makes with the base of the box. So highlighting it again. This is the angle that the rod makes with the base of the box. So we said this was 16. This was 26.9. So now to find this angle, we can use tangent. Tan theta equals to opposite, which is 16, divided by the adjacent, which is 26.9. So theta would be tan inverse of 16 over 26.9. And that gives us 30.7 degrees. That is the angle which the rod makes with the base of the cuboid. And this question says that ABCDEFGH is a cuboid. AB is 8 centimeters, BC is 5 centimeters, and GC is 10 centimeters. Work out the volume of the cuboid. So volume of the cuboid basically has the formula of length times width times height, which means we multiply 8 by 5 and by 11, which equals to 440 centimeter cube. Then it says Ivana has a pencil of length 13 centimeters. Does this pencil fit completely inside the cuboid? Now, if we look at the dimensions of the box, we can see that vertically the length is 11, which means the height of the box is 11. And the pencil length is 13 centimeters, which shows that if we put it just vertically, straight right in the box, it's not going to fit. It's going to be outside the box. because 13 is bigger than 11. If we try to put it horizontally, that is also impossible because 8 is less than 13. So the pencil will not even be able to go inside the box. The last option we have is that if we can put the pencil diagonally in the box, like this. So for it to be able to fit diagonally in the box, we need to show that the length AG is bigger than 13. Now to show that, we can connect A to C and G to C to create this right angle triangle, and then use this right angle triangle to find AG. So now first we find AC using Pythagoras. As you can see, this is another right angle triangle. So AC squared equals to 8 square plus 5 square, which is going to be 64 plus 25. 64 plus 25 is going to give us 89. Square root both sides, and that equals to 9.43 centimeters. Now, AG would be 9.43 square plus 11 square, which is 89 plus 121, 210. Square root both sides, and AG equals to 14.5 centimeters. As you can see, 14.5 centimeters is greater than 13 centimeters. So yes, it will fit completely. And this is your working, which helps you decide that. Then it says calculate angle CAB. So to calculate angle CAB, let's go back to the diagram. CAB, so that's this angle over here. So like we said before, this is a right angle triangle. We have the opposite, which is the length opposite to the angle. And we have the adjacent, which is the length on which the angle lies. So using tan, which is equal to 5 over 8, we can easily find the value of theta and just tan inverse of 5 over 8. And that gives us 32 degrees. Then it says calculate angle GAC. GAC is this angle. So to find this angle, AC was 9.43. So once again, we apply tangent. Tan theta equals to 11 over 9.43. Theta equals to tan inverse of 11 over 9.43. And that gives us 49.4 degrees. That's your angle GAC. It says the diagram shows a prism with a rectangular base ABFE. The cross section ABCD is a trapezium with AD equals to BC. AB is 8 centimeters, GH is 5 centimeters, BF is 12 centimeters, and angle ABC is 70 degrees. We have to calculate the total surface area of the prism. So total surface area means that you find the area of all of the faces of the shape, and then we add them up to find the total surface area. So they've told us that AD equals to BC. So AD equals to BC. So these are all the same. And AB is 8, BF is 12, GH is 5. So what we can do is we can first begin with finding the height of the trapezium. If we draw a line from point C towards the length AB, this perpendicular height is what we're going to find, which will be the height of the trapezium. Now, if GH is 5, that means DC is also going to be 5. Length AB comprises of DC because they're both parallel. So DC is part of AB, which means if this is 5 and this is 8, if we draw another line from over here, this length and this length would be found by subtracting 8 and 5. So 8 minus 5 is going to give us 3. Now, since these two lengths are equal, it means that the triangles are congruent. This is going to be 1.5 and this is going to be 1.5. Now, to find the height, I'm going to draw a separate triangle. This is point C, this is point B, this is where the right angle is. This is 70, this is 1.5, and we need to find the height over here. So using SOHCAHTOA, we can find this length. We have the adjacent, we want to find the opposite, we have the angle. So tan of 70 equals to h over 1.5. 1.5 times tan 70 gives us the value of h, which is 4.12 centimeters. Now that we know the height of the trapezium, we can easily find the area of the trapezium faces because the area for trapezium has a formula of 1/2 times height times sum of parallel sides. So that's going to be 1/2 times 4.12 times 5 plus 8. So that's going to give us 26.78 centimeters square. As you can see, we have two trapezium faces because it's the cross-section area. So total of the trapezium face is going to be twice of 26.78. Then we have 4 rectangular faces as well. The top is a rectangle, the bottom is a rectangle, and we have side faces, which are also rectangles. For the side faces, we can see we have the base, we don't have the width for that. So to find the width for the rectangle faces, we'll once again use SOHCAHTOA and find the length of CB. So if this is what we're trying to find, let's call that X. We have the adjacent. So I'm going to use cosine because we're trying to find the hypotenuse. So cos of 70 equals to 1.5 over x. X equals to 1.5 divided by cos of 70. And that equals 4.38 centimeters. So now if we notice, we have the dimensions for these two triangles. We already have the dimension for the top triangle, 5 and 12, and for the bottom is already given, which is 8 and 12. So now to find the area, total surface area is going to be 12 times 4.38 times 2, because 2 faces, plus 5 times 12. We're not timesing this by 2 because it's just the top face. Bottom one is 8 times 12. And then lastly, the cross-section areas, twice of 26.78. So that's going to give us 314.68, which we can also round to 315 centimeters square. That is your total surface area of this prism. Part B says the perpendicular from G onto EF meets EF at X. Show that EX is 6.5 centimeters. So the perpendicular from G to EF, and it's meeting EF at X. They want us to show that EX is 6.5 centimeters. So we know that this was 70, which is going to be the same because the trapeziums are identical. This we found to be 4.38. So if we find XF, which is a part of the 8, and subtract that from 8, we can easily find EX. So to find XF, we'll use SOHCAHTOA again. But if you realize, we don't need to find XF because we already found that in part A, which was the same as 1.5 centimeters. So EX is going to be 8 minus 1.5, which is equal to 6.5 centimeters. That's how you prove that EX is 6.5. Then it says calculate AX. So drawing this back again, this is where X was, and they want us to calculate AX. This is X. So this diagonal is what we need to calculate, but this diagonal is meeting A and X, not A and F. This would still be a right angle triangle because it's a rectangular face. And we know that EX was 6.5. So if we draw this right angle triangle separately, this is E, this is X, and this is A. EX is 6.5, AX is what we need to find, and AE is 12 because BF is the same as AE. So we can use Pythagoras. X squared equals to 6.5 squared plus 12 squared. That's going to be 42.25 plus 144. That gives us 186.25. We can square root both sides. And X would be 13.65 centimeters. That is your length of AX. Then it says calculate the angle between the diagonal AG and the base ABFE. AG and the base ABFE. So same place, we're going to make this triangle, which meets at X over here. And we have the right angle over here. We just found AX, which was 13.6. They want us to find this angle. So if you remember when we were trying to calculate the area of the trapezium, we already found the height of the trapezium, which is basically the same as GX, which was 4.12 centimeters. So now if you notice, we have the adjacent, we have the opposite, and they want us to find the angle. So we'll once again use tan. Tan theta equals to 4.12 over 13.6. Theta is tan inverse of 4.12 divided by 13.6. And that gives us 16.8 degrees. That is the angle which the line AG makes with the base ABFE. In question 4a, it says that a rectangle measures 8.5 centimeters by 10.7 centimeters, both correct to one decimal place. Calculate the upper bound of the perimeter of the rectangle. So since both the measurements are correct to one decimal place, the degree of accuracy is 0.1. So when you're trying to find the upper bound and lower bound, whatever the degree of accuracy is, you divide it by 2 first. So 0.1 divided by 2 is going to be 0.05. Now this measurement is added or subtracted to the given lengths to find the upper bound and the lower bound. So since we're talking about the upper bound of the perimeter, when you're trying to find the upper bound of an equation where things are being added, you use all the upper bound values. So upper bound of the length would be 10.7 plus 0.05. Since it's the upper bound, we add 0.05 to it. So that's 10.75 centimeters. Then upper bound of width would be 8.5 plus 0.05, which is 8.55 centimeters. So now the perimeter would be twice of 10.75 plus 8.55, and that equals 38.6 centimeters. That is the upper bound of the perimeter. Let's say they were asking for the lower bound of the perimeter for the rectangle. Then you would subtract 0.05 from 10.7 and 8.5 and then calculate the perimeter. If they were asking you to find the area, you would once again find the upper bounds and then multiply those depending on like what they were asking for. Part B says ABDF is a parallelogram and BCDE is a straight line. AF is 12 centimeters, AB is 9 centimeters, angle CFD equals to 40 degrees, and angle FDE is 80 degrees. Calculate the height of the parallelogram. So if AB is 9, DF is also 9. Now if you look at this right angle triangle, we have the hypotenuse, we have the angle, and they want us to find the opposite, which is the height. So we use sine. Sine 80 equals to h over 9. 9 times sine 80 equals to h, which gives us 8.86 centimeters. That is the height of the parallelogram. Then it says explain why triangle CDF is isosceles. CDF. So we said that this was 9. We find this angle. So that's going to be 180 minus 80. That's 100 degrees. So this is 100. Now if you find the third angle, DCF, that's going to be 180 minus 100 minus 40. That's 40 degrees. So what is the condition for an isosceles triangle? We have two equal lengths and two equal angles. So over here, as you can see, we have two equal angles, which means this and this are equal. And this is also going to be 9. And this is going to be 3. Because 9 is a part of 12. So 12 minus 9 is 3. So as you can see, two equal angles, two equal lengths, which already meets the condition for an isosceles triangle. So because angle DCF equals to angle DFC. Then it says calculate the area of the trapezium ABCF. So area of a trapezium ABCF. So what are the conditions for a trapezium? We need two parallel sides. As you can see, these two are parallel. And we already found that this was 3 and this was 9. And the height was also found, which was 8.86. So we already have everything. We have the perpendicular height, we have the parallel sides. So you can easily use this in the formula to find the area of the trapezium. So that's going to be 1 over 2 times 8.86, which is the height, times the sum of parallel sides, which is 3 plus 12. That gives us 66.45 centimeters square. That is your area of trapezia. Then part C says that ABC and D are points on the circle center O. Angle ABD equals to 21 and CD is given as 12. Calculate the area of the circle. So to calculate the area of the circle, we need to remember our circle theorems for this question. First circle theorem we're going to focus on is angles coming out of the same chord. So if you notice, angle B and angle C are coming out of the chord AD. So angles in the same chord are equal, which means this would also be 21. So that's our first circle theorem. Second circle theorem over here is that CA is the diameter. Why is it the diameter? Because it's passing through the center and both C and A are touching the circumference. So if C is the diameter, that means angles coming out of the diameter touching the circumference are 90. So angle CDA is 90 degrees, which makes it a right angle triangle. So if it's a right angle triangle, we can easily find the length of CA, half that, because half of diameter equals to the radius. So first, using SOHCAHTOA, I'm going to find CA. We have the adjacent, which is 12. We need to find the hypotenuse. So cos of 21 equals to 12 over CA. CA is 12 divided by cos of 21. And that gives us 12.85 centimeters. Now radius is half of the diameter, which gives us 6.425 centimeters. Since the area is what they're looking for, area has the formula of pi r square. So pi times 6.425 squared, and that will give us 129.6 centimeters square. That is your answer. Then part D says the diagram shows a square with side length 8 centimeters and a sector of a circle with radius 9.5 centimeters and sector angle at x degrees. The perimeter of the square is equal to the perimeter of the sector. Calculate the value of x. So if it's a square, all lengths are equal. They're all 8. So perimeter of square would be 8 times 4. That's 32 centimeters. Then if both the perimeters are equal, that means 32 equals to 9.5 plus 9.5 plus this arc length. So twice of 9.5 plus x over 360 times 2 by 9.5. Arc length has the formula of angle over 360 times 2 pi r. And the perimeter of a sector is your radius times 2 plus the arc length. Remember, perimeter is always the boundary of the shape, not the space that the shape occupies. So 2 times 9.5 is 19. And this over here simplifies to pi times 9.5 divided by 360 is 0.1658x. So we do 32 minus 19 divided by 0.1658, and that is going to give us x equals to 78.4 degrees. That is your angle of this sector. In question 15, it says the diagram shows three shapes that are mathematically similar. The heights of the shapes are in the ratio small is to medium is to large is 1 is to 5 is to 8. Find the ratio shaded area is to total unshaded area. We answer in its simplest form. So if we do small is to medium, medium is our shaded and small is our unshaded. So that's 1 is to 5. Now if you remember the concept of similar shapes, length 1 over length 2 squared equals to area 1 over area 2. So if we do 1 over 5 squared equals to a1 over a2, that gives us 1 over 25. That is the ratio for area 1 is to area 2, where area 1 is for small and area 2 is for medium. Actually, let's replace the 1 and 2 with small and medium so that there is no confusion. Okay. Now, if we do medium to large, so that's 5 is to 8. So 5 over 8 squared equals to area of medium divided by area of large. So that's 25 over 64. Now to find the total unshaded region, we will do 64 minus 25. And then plus 1. That gives us 40. And shaded area we found to be, which is the medium one. So that's going to be medium minus small. So 25 minus 1, that's 24. So that's 24 is to 40. If we simplify it, 24 divided by 8 is 3, and 40 divided by 8 is 5. So 3 is to 5 is your shaded area, is to total unshaded area.